Good afternoon. Will this work? Yes, it works. We showed this picture, our colleagues in this collaboration that was just named the Event Horizon Telescope collaboration last April 10. This day marked a high point in the careers of several hundred scientists and engineers that had worked to make this one image for quite a long time. In my own case, my career started about 40 years ago when we started using the technologies for this to take a look at distant galaxies. This image actually is a look at the very central region, at a black hole, a mass of an enormous density that combines billions of masses like the Sun in a volume that is comparable to our solar system that we just learned about how it can be explored. Billions of stars compressed into the space of the dimension of the solar system. This object, thought up by Albert Einstein more than 100 years ago in his theory of general relativity to be possible, this object is so dense that the mass, the gravitational attraction of this mass is so strong that matter and light, anything that comes too close, will be sucked up, cannot escape anymore, and we can't get any information from it. So here you see the solar system all the way to Pluto, and you see Voyager 1, a satellite that was sent out in the 70s that's still exploring outer space. That's the furthest object that has ever gone away from Earth. And this black hole fills, this dark shadow fills just about the dimension of that system. So we skipped that picture. That the result that I'm talking about was a momentous success for us as scientists. It got quite a bit of attention in the scientific community. Why? Because it was a remarkable breakthrough in technical capability to make such an image with the sensitivity and the precision. The image quality was a breakthrough. At the same time, our result confirms that these black holes can exist in galaxies, and they confirm the theory, as I just said. But this was also, and I expect some of you will have seen this was also a result of great public interest. That's perhaps why I'm here at ChangeNOW, because of this interest that we had. And I'm not going to touch this to screw it up, but I like what the German Spiegel said about what we did. We allowed for the first time a glimpse at the edge of space and time. Those of you who do physics or know about physics know that in the black hole some very strange things happen, and you do actually get at the edge of the time and space that we can experience if we get close. So interest in the sciences, but also interest in the public. And the giant black hole, this huge mass, sits at the center of a galaxy. In this case here, it is a black hole that is still being fed by matter, stellar matter and gas that comes around this compact object, is sucked up in a swirling storm of matter and light. And the idea that we had some 20 years ago, when we only had these theoretical models, when we didn't know these things existed for sure, was to make an image. An image that the French astrophysicist Jean-Pierre Luminet already in the 70s calculated from Einstein's equations, and this is a hand drawing but based on computer data, showed what you would see. What would you see of a black hole that sucks up this matter and light and gives a very strange appearance perhaps? And so what you see is of something that sucks up everything. First of all, you wouldn't expect to see anything. But imagine you have a white sofa and a black cat sitting on that white sofa. That is comparable to the situation we have here. The matter around the black hole, as it is swirling in, is generating light emission, not only in the optical, but also in radio and other wavelengths. And it's that emission that we see, and the shadow is the rendition of the black hole from which no such emission comes out. And then you have various strange effects that I'm not going to tell you and bore you with in detail, but you have very strange gravitational effects because of this huge mass that lead to a distortion of the image. So the prediction of theorists was we would see, if we could make such a picture, distorted images. Now, there's no way to do this in the optical, taking a telescope, even a huge telescope, even a space telescope, in the optical cannot give you such a picture. To do such imagery, it's necessary to go to different wavelengths, and this is a telescope we operate in Chile on a 5-kilometer high site, the Chatnantor Desert. It's one of the most precise instruments to detect radio waves from space at a very, very short wavelength, at a wavelength of 1 millimeter. There's only a dozen or so such telescopes around the world. None of them has a power, a resolving power, good enough for what we needed to achieve. What we needed to achieve was an image quality, a resolution, millions times better than the human eye. An incredible precision. And so the idea we had, and the trick we envisaged and actually achieved, is to use such telescopes around the globe. I said there's about a dozen. In 2017, when we did our measurements, we used about 8. We used 8. And these are distributed from Europe to Asia to South America and even the South Pole. We used telescopes like the one you just saw at all these sites. We observed this galaxy, which is located at an incredible distance of 55 million light years. Light travels at the speed of 300,000 kilometers a second. And the distances we're talking about are the distances the light can travel in a year, and then millions of that. So an enormous distance that can't easily be imagined. This very distant thing, we receive the very weak radiation. These instruments are very, very sensitive. We record the information on digital recorders that go onto magnetic disks, and we transport these magnetic disks with airplanes back to Germany and to the US, to MIT, where we spend a lot of time analyzing the data, combining them, and extracting the image out of these observations. These are the telescopes. And to make this possible, we had to bring the talents and the enthusiasm of a large number of people together. We started with some 50. By now, we have more than 300 people working, mostly graduate students and postdoctoral people, but also experienced engineers working on the various aspects of doing these observations, analyzing them, and interpreting them by running theoretical models to compare. So what started as a scientific idea, as a vision, ended up as a joint project for hundreds of people, with a lot of problems associated to that. We took quite a while until last year, because as the part of the scientific process, and I think that's an important aspect, we didn't want to trust our results too early. We wanted to make absolutely sure that what we would show was a robust image. And so we had various teams working independently, trying to do this little bit of image reconstruction on this picture. And seeing what you see here on the left side, theoretical predictions from simulations with computers, predicting what the structure that you would see might look like, and actually on the right, the real picture that came out, the final picture that came out, gave me, when I first saw this, an amazing feeling of accomplishment. We showed our results to the scientific community in what we do. We are scientists in basic research. We write incredibly long and complicated papers that go into the community, are vetted and compared, and that's the normal thing. But we also showed, as I said at the beginning, our results to the world. And none of us really had an expectation of how substantial the interest of the public would be in this very far away, seemingly arcane scientific result. On the next day after we went public, the newspapers around the world showed this image on their front pages. Articles, magazine, TV things, everything possible was happened, and this went viral in any possible sense of the way. We had no idea that that could happen, and it's hard to explain why it can happen. It's perhaps therefore fitting to offer my thoughts on what happened. If you look at the news any day, but also those days, they were Brexit, as they are today. There were disasters and catastrophes, wars, and examples of bad collaboration about the world. We brought out of this obscure scientific community a result that is positive, that strengthens our understanding of the universe, of the most fundamental properties that hold not just space, stars, galaxies, planets that you've seen, but also our own Earth together. And I think it is this fascination that flipped over for one moment in time and has done so ever since. from the scientific community to the public. This image, actually, you'll see in many, many circumstances that have nothing to do with science. It's something that transcended into the public world. Have we changed something with this? Well, it's up to you to decide that, but for my view, we have made a change in that we have given an example of how determination to pursue a vision and collaboration on a worldwide level is possible to achieve great results. Thank you very much for your attention.
Thank you, Anton Zensus. So a couple of questions. This scientific breakthrough, can it inspire progress in other sectors on Earth? I mean, because many technologies were used. You were talking about this network of telescope, for instance. Will it be able to, I don't know, tackle the issue of global warming or something else on Earth?
You're right that we're using technologies that are applicable in other areas of sensing in the widest sense. There's similar technologies that are used from spacecraft to observe the Earth. The receiver technologies that are used and so on are all similar. Our research is basic research, and so oftentimes there is no immediate benefit for the problems that we have on Earth. But if you take the long view, then there's always new understanding that comes from basic research, and in astrophysics that is exactly the case. So if you think of Einstein's theory 100 years ago had no relevance, and we are now still testing this theory, it still works for us, it had no immediate relevance. Today there wouldn't be GPS possible without the corrections from that. Astronomers, you can say, well, maybe this is not relevant for my daily life. Astronomers observe the skies for millennia. For as long as humans live on Earth, we observe the skies, and from these observations of the motions in the sky, later on the physical models were derived that now govern everything and every technology that we use. So absolutely do I think there is going to be a long-term benefit. In the short term, we make a contribution by bringing people into our field that then later on work in all the other fields.
You were saying that many hundred people, more than 300 people, worked on to collaborate it together worldwide. Astrophysicists, engineers, people really from different fields. Was it hard to coordinate everything, the whole team? And what have you learned from that experience, and that can inspire leaders in other sectors?
It was not easy. It was at times very difficult. Imagine you have competing groups around the world of professors with their students and organizations that all have different ambitions, different aims. Bringing them together behind this one goal required a great deal of coordination, of convincing, and of work. What it has taught me is humility over the collaboration with people, because none of this would have been possible if it wasn't the case that all these people that make contributions were highly talented. We're not a company where you decide, or an organization where you decide top-down what people need to do. We have to rely on the talent, imagination, creativity of people. And working with those people, good people, is incredibly rewarding. Still, it's not necessarily easy, but at the end, if the result comes out, it's a great success.
You were saying that 4 billion people, more or less, look at this picture of the black hole worldwide. So, you were surprised by the enthusiasm of the general public. What can we expect to learn more about black holes this year?
There's a lot of, well, let me just say very briefly that I don't say 4 billion, but more than 1 billion people probably have seen this in one situation or another, even just glanced at it. A lot of people have been interested, and so the estimates of the media go to 4 billion. That's half the population of the world. I won't argue that we have reached so many people myself. We will see more results because black holes are the subject of astrophysical research from many angles. We'll see more of that, and we may see very soon. This picture that you see is something that we look at into the universe. And what we may see soon is the reverse view, some view at the center of our own galaxy. That's what we're currently working on, and that's what we hope to bring home soon.
Thank you so much. Anton Zensus.